All right. Hello, everyone. Today was day 19 of Advent of Code. And today was an interesting puzzle again. However, there was loads of parsing required. So yeah, let's go through it. So first, we'll have machine parts today, and each part has four attributes, which are abbreviated by X, M, A, and S for these names like aerodynamic, shiny, and so on. And we're passing those parts through a workflow. And a workflow is given like this. I'm thankful that would give us the name, first the name, and then we have a few conditions such as A smaller than 2006, and then it would tell us the name of the next workflow we're supposed to pass this part to, and in the end, a final name of a workflow if none of the previous conditions evaluated to true. And we have a list of workflows, and we're supposed to pass the part through all of them until we reach either a state A or a state R, which means accept or reject. We also got a list of parts, and for all of those, we need to evaluate if they end in a state A or state R. And then for a solution, we need to consider all the accepted parts and then take those four values and add them all together to get one value for each accepted part. And for the solution, we just sum this value for all accepted parts. All right, so let's have a look. As I said, there will be a lot of parsing. But first, we define a comparison. So we have these two comparison symbols, and we can define the corresponding comparison function. And then it will be useful to keep track of the names of things. So first, we refer to a part will be a dictionary that maps a string, which will be X, M, A, or S, to an integer value. And then a condition we represent as a tuple of three values. So an attribute, which will be X, A, X, M, A, or S, and or none if for the last condition that's always true. Then we have a comparison, which will be one of those comparison symbols, and we have a value, which will be an integer. And then a rule will consist of a condition and the string, which tells us the next workflow to go to if the condition is true. And finally, a workflow will be a list of rules, and we'll have a dictionary of keep around the dictionary of workflows. Okay, then the parsing. So first, the main parsing function will just go through the lines, and at first we parse the lines until we find a line that's equal to that's an empty line. And before that, we just go through all the lines and we pass the workflow corresponding or encoded in this line. And then we collect all the workflows in a dictionary that maps the workflow name to the list of workflow rules. Once we found an empty line, we switch to the second mode and pass all the part ratings. So there we just go through the remaining lines, and for each line we pass the part rating encoded in this line. How can we parse a workflow? So a workflow looks like this string, and first we find the workflow name, which will be the beginning, by splitting the line by this curly bracket, and then we get all the rule strings, something like this, by splitting this workflow body by the comma symbol, and then for each rule string in this list of rule strings, we just parse the rule from the rule string, and that will give us a list of rules we return. The rule parsing itself, so there will be a few rules looking like this, and the final rule will look like this with the last curly bracket still on there. So first we write the code for passing this final rule. So if the rule string ends with this curly bracket, then there will actually not be any conditions. So we represent this by setting the attribute to none. And then the new workflow name will just be by these first letters, by all but the last letter. Otherwise, for this kind of rule, we first split by the colon in order to get the name of the next workflow. And then we check which of the comparison symbols is in this condition string. And based on this, we just represent the rule as the attribute, the comparison symbol, as well as the value. Okay, that allows us to parse all the workflows. As a second part, we still need to parse the parts or the part ratings, which will be easier, fortunately. So that's our input kind of line that we have to parse in order to get the part rating. So that nearly looks like a Python dictionary. What we need to do is just replace this equal sign with a colon, and then for each of the letters in XMass, we just wrap the letter in single quotes, and then we can use Python's standard eval function to evaluate this dictionary represented by this string. Okay, that's it for the parsing. So now we can think about solving the problem. So what we need to do is apply the list of workflows to a particular part and starting at the current rule name. The first thing we check is if the current rule name is either reject or accept. In this case, we're done. We found the final state and we just return this rule name. Otherwise, we go through all the rules in the current workflow, and this will have a condition and a new next workflow name. And first we check if the condition is this last condition that's always true. So we represented that by having the attribute set to none. In this case, we know in any case, we go to the next workflow. And so we recursively apply this function to the part, but this time starting from the next workflow name. Otherwise, we get the comparison function by this dictionary we defined at the beginning. And then we apply this comparison function to the attribute of the part as well as the value. And if it's true, we're told that we need to apply the workflow to this. We're supposed to move to the next workflow based on this next workflow name. So we again recursively apply this function. And if it's not true, we're supposed to continue with the next rule. So we just do nothing and we continue with the next rule in this for loop. All right, so that's the function that allows us to apply the workflow to a part. And that will allow us to solve the problem. So we just parse our input. Then we go through all the parts. And we evaluate the final destination by recursively applying this apply workflows function. And we start with the in state. And finally, we check if the destination is accept. Then we sum all the values of this part, or all the attributes of this part, and that we'll add that to the solution. We should probably test that works on the test input. That looks good. So we also run it on the real input, and it also turns out it gives us the right solution. For part 2, it turns out we're not supposed to check this process only for the parts that we are given, but actually for every possible part which has attributes within from 1 to 4,000. So if you do that naively, that would take 4,000 to the power of 4 parts to check. So that's clearly too big. So we need to be a bit smart about that. So we consider is ranges of values. So we define a range which is given by the lower end, the upper end, and then we define some convenience methods such as contains. So that just checks if a particular value is between lower and upper and the ends are included. Or if we want to get the length of a range, we can also define that easily. Then what we want to do is split those ranges by conditions. So in particular, we get a value and a comparison and want to split the range into 2 ranges. So first, if the comparison is the smaller sign, then the true range will start from lower and go all the way up to value -1. And the false range will start from the value and go all the way up to upper. Otherwise, if the comparison is the greater sign, then the true range will be the larger one. So it go from value +1 to upper, and the false range will be the lower one, starting from lower and going to value. And then we just return the 2 new ranges. That will be useful. And then what we consider is boxes of the input. So a box is essentially 4 ranges. For each of the letter in XMath, we will have 1 range of values that tells us which kind of parts are in this box. And then we have a similar function to before, but we want to find accepted boxes and within a particular box. And for that, we of course need the dictionary of workflows and the current rule. And similar to before, if the current rule name is accept, then the whole box is accepted. So it's nice to return a list containing the whole box. So our result the result of this function will be a list of box and not just a single box. So we return a list, in this case, just containing the box itself. Otherwise, if the rule name is reject, that's also easy. So then there will be not a single part within this box which will be accepted. So we return an empty list. Otherwise, we somehow have to apply this workflow. So what we do is we have a list of accepted boxes, and then we go through each rule to give us a condition and a next workflow name. And first to check if we add this final rule, which the condition always evaluates to true. So again, we have the attributes set to none to represent that. And then we know we're supposed to move on to the next workflow based on this next workflow name. So we just have a set of, so we just generate a list of new accepted boxes by applying this function to the starting at the next workflow. And then our list of accepted boxes, we just extend it with these new accepted boxes. Otherwise, we need to consider a particular rule. So for that, we consider the attribute. So this will give us a particular range for this attribute. And then we split this range into the range of true values and the range of false values. And then if there's at least one particular, there's at least one value for which this true range contains, So if the length of this true range is positive, then we know that for this particular range, we need to continue. So then the new box will look like the old box, but for this particular attribute, the range will be given by this true range and not by the full range anymore. And then for this true box, we just apply the rules. So what we supposed to do is go to the next workflow and continue from there. So that's what we do. And we find the accepted boxes within this true box, starting from this next workflow. And again, that will give us a list of new accepted boxes. We append that to the accepted boxes, or we extend the list of accepted boxes with these new accepted boxes. Okay, so last part we need to consider is all the values in the false range. So we update our box and set the range of this particular attribute to the false range. And then first we check if the false range is empty, is there not a single value in it. Then we break out of this for loop, so we don't need to consider it anymore because there's no values anyway. Otherwise, we just continue to the next rule and apply this part above again for the next rule. Okay, and that should build up this whole list of accepted boxes, and in the end return all the accepted boxes that tell us all the parts within this box that evaluate to accept. So we can use this function to solve the problem. So we parse again our input. This time we only care about the flows, not about the particular parts we're given. And then our starting box will have each attribute range from 1 to 4,000. And then we just call this find accepted boxes function on the starting box with starting state in. And that will recursively apply this function again and eventually give us a list of accepted boxes. So then all we need to do is we have to go through all these accepted boxes and just get their size to know how many parts actually lie in this box. And getting the size is also relatively straightforward by just considering the range for each attribute and multiplying the size by the length of this range. Okay, so that was it for day 19. I hope you enjoyed today's puzzle with Xmas and boxes and accepting it and rejecting them. And yeah, best of luck for the future and see you around.